Dear students, today we'll discuss about session 40. Session 40 is called as comparison of van der Waals isotherms and Andrews isotherms. So, as we know that van der Waals are a derived theoretical equation for an ideal real gases, and Andrews have been derived this experimental for isotherms for the carbon dioxide. So both have been conducted in a one conducted theoretical expression for real gases, and another one is a conducted experiment on real gases. So we'll see. Let me see how they concluded. So comparison of Andrews isotherms and van der Waals isotherms like this. So we know that van der Waals equation of a state for a real gases is called as P plus A by V square into V minus B is equal to RT. So if I rearrange this equation, we get P is equal to RT by V minus B minus A by V square. We know that at V is extend to infinity, P is becomes 0, and as P is becomes B, so P is also infinity. A family of curve P versus V for carbon dioxide for various temperatures are for under van der Waals isotherms, where A and B for van der Waals equations, A is called as 7.226 2 into 10 to the power of 2 Newton per meter to the power of 4, and B is equal to 1.91 into 10 to the power of 4 meter cube for carbon dioxide as shown in figure. See, these are the two diagrams have been drawn. So this is the van der Waals. Left side is called as van der Waals isotherms, and right side is called as Andrews isotherms. So by looking at these two graphs, we can draw the two things. One, it is called as similarities of these van der Waals and isotherms, and the differences in van der Waals and isotherms. Now let me see first what is called as similarities. See, at critical temperature, both the curves shows same point of inflection or critical point with horizontal tangent. The temperature above the critical temperature, the curves are similar, and those experimental curves agrees with the critical theoretical values. At below temperature, means temperature below the critical temperature, ideal gas behavior is absent in the both van der Waals and van der Waals. So what are the differences in this isotherms? Below the critical temperature, van der Waals isotherm shows horizontal portion during liquefaction, but van der Waals shows some curves showing a turning point. This cannot be understood as follows. If the liquefaction starts at A, we could have got a straight line AB. Thus, AB represents an unstable state of supersaturated vapor gas state, composed of vapor between saturated state without any liquefaction. The portion dA represents unstable state of superheated liquid A state heated behind its boiling point, but yet in a liquid phase. Second one, since Andrews curves represent only a steady states, these portions AB and DE are not experimentally proved. The portion BCD represents an anomalous behavior. It can be explained as it shows the decrease in volume with decrease in pressure, which is impossible in practice. This indicates the limitation of van der Waals equation. So these are the differences and the similarities between van der Waals isotherms and Andrews isotherms. So in this session, we deals about called as some of the questions. What is critical point? A point where the properties varies, a point where properties same, a point where density varies, a point where density is same. So you know that a properties where all properties are same. So do the density of vapor and liquid becomes equal at critical point? So answer is yes. So both vapor and liquid at critical points, both densities are same. So what is the critical volume of a gas? What is critical volume of a gas? The particular temperature of a gas as it gets liquefied, a particular volume of a gas as it gets liquefied, a particular pressure of a gas as it gets liquefied, none of this. So answer is B, a particular volume of a gas as it gets liquefied. So when van der Waals equation reduces to ideal gas equation, pressure is large enough, temperature is large enough, volume is large enough, none of this. So answer is volume is large enough. So what happens to the compressibility of a vapor at critical point? So 0, same value, minimum, infinity. So answer is infinity. So these are the questions. So further you want to study for this topic, refer these are the test books on for this topic.